Alright, so someone asked this question, which is, I don't know the year. Yeah. So propose a reasonable mechanism for each of the following. So there were many questions. Now this is A, which we are supposed to do. Alright, you can see that there's OH here, there is hydronium, there is this compound. So from this giving us this is an alkane, it doesn't have a double bond, and this is an alkene which has got a double bond. So you can tell that there was elimination reaction which was taking place due to the fact that you have been given a base as well as the heat. You have been given heat, so it can tell again to say that this is an elimination reaction. And this is specifically to be called as acid catalyzed dehydration of alcohol. So now we are changing this ringed form which has got 4, which is to this which has got 5. How can we do that? First of all, we are supposed to, let me just write like the way it is, like this, then like this. Then I'm going to protonate this one so that it can leave. How? I'm going to bring this, which is called an acid. Then what will happen is that I need to protonate, in short, to add a proton there in order for this to leave, to be a good leaving group, since it's a bad leaving group, OH. So this, I'm going to get this hydrogen, then this bond will go. What will happen is that it will be something like this. Then this one, it will be like this, then here like this. That's the product that we are going to have. We are going to have water because we have added the hydrogen there. So now what will happen when we reach that? This guy now will leave, will go on its own. Then the one that you're going to have is when it goes as a good living group, then you're going to have something like this. Then here you're going to have a positive, because it has lost a bond. This one has gone, and you're going to have a carbocation. So now this carbocation, when you look at that one, it is not stable because it is the one which is called a secondary carbocation. It needs to be a tertiary most of the time. So this is not stable. What are we going to do? We are going to make this like the way it is. This now we are changing this cyclic form into this which has got 5 shape. How? I'm going to show that I've gotten this one. Then I'm going to attach itself here. So this bond has broken and is going to attach itself here. So what will happen is that it will be something like this. Then it will be something like this. Okay, then here like this, and put like that. That's this one. Then here it will be something like this. Then this bond which was here, this one here, it has so you can see that this one is like this, then there's something like this. So here is this one, that's this part, then this part is this part, this part is this part, then this part is this part here. So now because this bond here which was here, it has broken and has attached itself here, so I'm going to attach it here like that. Then there's this part now which I'm going to show like this, you see. So now when I reach there, I'm going to say that since now this one has come to attach itself, this positive charge, it will be here now like that. So now I'm going to say like that one, then like that one, like that one. So to be something like this, then here like that. So what we want is to neutralize this bond. Now, either by using a Z-save or Hoffman rule. Now, how can we use a Z-save or Hoffman rule? So now, there's something like this. When you are given this base, you can see that this is a less bulky base, and it favors attacking. What type of the rule is Z-save. So now, how are we going to do that? So here there are 2 hydrogen. Then here there are 3 hydrogen, but here there's 1 hydrogen. So when you are given such a question with a less bulky base, you're going to get that water which has been formed like this. This is the water that was formed here. So we are going to attack the hydrogen. Which hydrogen is this hydrogen here? So we're going to get this hydrogen. Why? Because of the less bulky base, which has favored attacking the less substituted hydrogen, not the more substituted. So where there is a less substituted hydrogen, that's the one that we are going to attack. That is the safe. So here this bond will come and will break and will form a double bond there. So what will happen is that we're going to have our so it will be, our product will be like this, like this, like this, like this, like this. So here there's a double bond, the one that has been formed. This one has been neutralized, the carbocation or the ion there. Then here to be something like here to be something like this. Okay, like this. Okay, let me try to do this. Okay, so it will be something like this, something like this, something like this, something like this. Then here it will be something like this, like that. My pen is not working so well today. Let me just change this. Okay, it will work. Good. Okay, so it will be something like this, something like this. Then here double bond, and that's how this is. Another way people can do this, like this. Just like that. So that's the compound which is this one. This is just how you go about that. Thank you.